I start with vehicle simulator at Reutlingen University. My name is Thomas Walzer. This to the end of this month research associate at Reutlingen University. My topics were IoT. There I did microcontroller parts and the driving simulator, smart textiles, and I'm kind of the maker of the department. And yeah, I contributed to the EG connectivity. So I worked for a Reutlingen University on AGL since 2018. My work was from the sensor to the backend all around AGL with open source software and open hardware or our self-made hardware and a lot of management of the students' project. Before we started with AGL, we had a driving simulator from PhD thesis. The focus was on the driver data and CAN data generated from it. The purpose of this PhD thesis was development of a driver assistance system. And we had no actual human car interaction. It was just the notifications from the car. But that gave us the basic idea for AGL. I did my bachelor thesis on that topic, and I did something service-based on Java OS GI to have an infotainment system. And it not worked that good, so later we found AGL and started. Our vision for for that what we did at Reutlingen University, create a modular driving simulator environment that could be used at Reutlingen University for topics in automotive research and education. It should be a framework for textile and design. We have interior designers, and all time I saw their cool models but just had paper slides or something like this in their model. And that was so annoying because we from the computer science faculty had the technology to bring technology in it. And yeah, that was a bit sad. So that was the idea, to give them an environment or a framework where they easily could work on better prototypes. We have mechanics and mechatronics at Reutlingen University. And yeah, they are working on ECUs and all the stuff. So the idea was to bring them together to us, and the computer science for us with the driving simulation, with the knowledge of software of AGL. So maybe the vision was to create a small virtual car company at Reutlingen University that is more based on interaction, ECUs, and interior. So the vision of the actual driving simulator was a driving simulation that has only one connection to the outer world. So in simulation, and we shouldn't care about the simulation. We should have clear interfaces to get the values from the driving simulation in our system and back. The system should have AGL on board, at least in the IV system, additional with the ICE. And it should be possible to make different car classes and for example, trucks or small cars. We are working with 12 or 13.8 volt power supply as in the normal car at the moment, and it should be easy extendable with new hardware. For that, I designed an adapter from CAN modules for Arduino and so on via DB9 Connect. And the idea was the image on the right side. So that was the basic idea we started to create our hardware. And the concept for that was we have a simulation. The simulation is connected via LAN to the car interface. You can see that on the right side. There's also the power supply for the 12 volts. And from there, we have the CAN interface that connects with different channels to the driving simulator. AGL, IV, textile controls, and actuators are connected, for example, to one bus, the yellow, the gear, the steering wheel, and the pedals to another, the red one. So we want to separate that how like it is in a real car. So on the left side, you see the simulation that is just with a beamer. You see the backend, that was the part I showed before, and the red parts are on one CAN bus. So it's a steering wheel sensor with CAN bus, There are pedals, a shifter that was made out of an C64 controller, and you see the green parts here, AGL. The nice looking pictures are on the right side. So you see the blue LEDs everywhere, and that are a smart textile. We work later. I will talk later about that. So it was a research project, and we worked on the topic how to bring textile in the car as interaction surfaces to have a nice feel and not have the plastic parts. So yeah, we worked on that, and that is the prototype where we have thing in. So that is one part of the AGL platform. I was the maker, so sometimes it was really rapid prototyping, not that nice, and yeah. So, but we worked on up square on a CAN SL module or socket SL CAN module with the microchip audio system and a touchscreen applied to that. On the left side, in the smaller picture, you can see our green box. Now it's formally black, but it's the same. So it's the prototyping mobile development station that we had at Reutlingen University. Now I start with the simulation. Our driving simulation is OpenDS, it's Java based, and it has, you can see it on the link, and it has a service where you can send TCP strings to for the CAN bus. So we used exactly that function, and in the bottom you see a TCP string, not a complete, but one that we also used or part of that. So we send all the information to the next step, to the CAN interface. And then you can see in the terminal on the right side that we have the software that decodes or encodes the CAN messages from the TCP strings and send it over CAN, here in that example on virtual. So the CAN gateway where we're all doing this is based on the old driving simulator. We just ported the idea to Python and added a new CAN. The software opens a TCP server, which the driving simulation could connect. The driving simulation sends strings with the car data to the server, so all updates of the driving simulation with speed or an interval we can set will be sent to the gateway. The gateway will get the values and encode it to CAN and send it on the different CAN channels. And we also have the steering wheel sensor that has actual CAN values, and we are using that values, decode it and send it to the driving simulator. So we could control the driving simulation with a real car. The actual CAN gateway is a 6-channel gateway. It's working with the socket CAN drivers, and we have software prepared for the powertrain, the chassis, and the interior. So they are partly implemented. On the left side, the motor and gear we are getting from driving simulation and sent to the CAN bus. The chassis network is where we get our real sensors and push that values in the CAN gateway to bring it in the driving simulation. We could use the distance sensor of the driving simulation and push that in the body, but we didn't that yet. And then we have a part with the telematics where we have the IV system and the instrument cluster. And the idea is to push all the important information from there, from the other gateways in the telematics. That is, for example, the interior, the climate information that AGL could change that, or our interaction points, interaction surfaces that we could use the input of that in AGL. And we have at least not implemented the OBD or OBD2. Yeah, what I did for all that was generate an AGL CAN format from DBC. So this is the CAN pipeline, and the idea was the students go and create their or define their messages in Canoe, then create a database out of it, we export that database and then use one part in our CAN gateway. So we just import that database via CAN metrics and have the values in the CAN gateway and can decode, encode it, and send the data. The next part where we did some work, but it's not working at the moment, was convert that database to JSON, use a tool to convert that JSON in the right format for AGL CAN, and then create it and build the AGL CAN service for that. So the idea was in maybe 10 minutes, you could create your new messages and signals and use it in AGL. Maybe add an Arduino with exactly the same information, and you can control, create a touch control or something like. So the system starts with PySim to CAN. So that is the gateway software or the server software we have at the moment. If that is started, OpenDS connects and send message. Then the connection or the simulation is starting. We get also the value from the chassis, from the steering, the pedal, and so on. And then AGL can connect to the car data and work with that. So that was the first prototype we did. Through the last year, I have to start to bring it to the students in a virtual way. So I made one VM. OpenDS is just a service, a software that you can start on every machine. And PySim to CAN and all the CAN gateway are virtual and in a VM. So we connect OpenDS with that VM and connect then AGL through Cannelloni, which we included to the PySim to CAN connection with Cannelloni. So the next step I would do, if I could, would to push all the Docker weekend part or all the stuff in a Docker container, that it's much easier, because it was hard for some of the students to get VMs working and we have 5 different computers on 3. The VM worked without problems and 1 a bit tweaking, and the last one wasn't working. So it was really hard to find a good configuration. Yeah, what I said before, we're using actual pedals. So they are on the left side where ADC. I converted the ADC to an Arduino digital signal, used an Arduino CAN device or CAN module, and send the data to the steering sensor was sending the data directly. And you can see on the right side, this is our custom CAN adapter. So it's a DB9 connector to CAN with 3 ports, and it's a Y cable or Y adapter. So we bring the next. So then I came to the InBio project. It was smart textiles in car. You see this already. We have a capacitive sensor, an Arduino module, and use that. The concept is button on demand. So on the right picture in the top, you see the 3 main buttons. If you press one of the main buttons, you will get the information on the symbols on the same position. So the first is source. If you go to the climate, you have the fan up. And yeah, if you press 1, you get the 12 buttons working with that. On the right side, you see 1,700 LED matrix in the dashboard to get symbols out of that. And on the left image, on the bottom, you see some tries touch interfaces. So one part of the driving simulation was the map generation. So the basic idea below is we just use one part of OpenStreetMap and generate that. So we could drive on every place we want and try parts. And we made a bachelor thesis out of this. And that is the first part of the bachelor thesis, or the first try of a bachelor thesis. The impressions of the work you can see on the right, there is the part of the map. And on the left side, there's the presentation in the driving simulation through OpenDrive. So you could use that. Yeah. So what we also had, by partly finish, but yeah, I wasn't in the university the last time, so I have to try that they communicated to you is develop a HTML5 navigation app for a driving simulator. There was part the algorithm or the HEL service. There was not that further, but the UI, the interaction with the LEDs and the side app for work. The second project there, I don't know what is the current state, was developed on event-based system for interaction with the cars. So we used a geste sensor and an extension for HEL and user profile for the radio to switch the channels and the volume via key. So the output, what I did the last years was the CAN pipeline, the setup for students to start with AGL, a small getting starting AGL Git repo for me, and basic parts of the vehicle simulator, driving simulator for AGL. Thank you for your attention. Hopefully see you again. That was my last presentation for Reutlingen University. Thank you.